The next speaker is Ceschia from CESBIO, and he's going to tell us, in between SDGs, he will give us a break from SDGs, and he will tell us about the 4 per 1,000 initiative and the report that has just been launched. So I'm looking for your presentation. Here it is. So the floor is yours.
Thank you very much. This one works? Yeah, great. It's not very common for me to, I will present a collective work that has been coordinated by Sylvain Pellerin and Laure Bamia from INRA. It's about carbon storage, estimating the potential of carbon storage in the soil in France, and also its cost. Here. So a few words about the context. The objective is to reach carbon neutrality by 2050, and for this there are 2 pillars. First, of course, reduce our greenhouse gas emissions, preserve also the current carbon stocks, and increase carbon sinks through biomass, storage in the biomass and in the soil. So there was a scientific controversy about the potential for additional carbon storage in the soil, and that's what launched the 4 per 1,000 initiative. So it started after the COP21. So at the beginning of this initiative, there is a very simple calculation that the soils contain about 2,400 gigatons of carbon at global scale. The anthropogenic emissions of CO2 represent about 9.4 gigaton carbon per year. So an increase in the soil carbon stock of 4 per mille, so 0.4% per year, would theoretically compensate the CO2 emissions. So there were a number of political and scientific controversies about this initiative. Was it realistic or not? What were the constraints, sociological, technical constraints to do that? So it appeared that there was a need for an accurate assessment of this potential for additional carbon storage. And currently a lack of methodology and of economical approaches to do so. So INRA was appointed by the French Ministry of Agriculture and the French Environment and Energy Management Agency, ADEME, to carry out an advanced study on this topic at the national scale. So the objectives were to identify the carbon storing practices first, to assess and map the potential for this additional carbon storage in the soil following their implementation, then to assess their implementation cost and to propose some optimal cost-efficient strategy for adding soil carbon storage at the national scale by analyzing such curves like the marginal cost depending on the additional carbon storage. I will tell you more about that later. So the scope was the mainland of France only. We didn't consider land use change, no afforestation, for instance, no change in the production system or reallocation, no change in the demand or food regimes, only estimating what would be the additional carbon storage by changing some practices that are readily implementable. So the general organization, the study was carried out during 2 years, between 2017 and 2019. There were 2 scientific leaders, Sylvain and Laure, that I mentioned in the beginning. A multidisciplinary panel of 28 experts. I will go on quick on that. And a project team and an advisory board and technical committee. So the methodology that was used, first it was to define a baseline and the current By current, I mean between 2009 and 2013, so the current practices, and estimating the carbon storage with the current practices. So agro-climatic context was accounted for, technical economic context also, the modifications in the management practices that could be considered, and some applicability criteria. All these were required to estimate some potential applicability per hectare, and then the additional carbon storage that could follow the change in practice was estimated per hectare, and by using different tools, different approaches. The technical cost was also assessed for each management practice change. And then the results were aggregated at regional and national level. The cost of each practice was calculated, and then at national level there was an estimate of the technical carbon storage potential, and also an economic carbon storage potential, by minimizing the total cost of carbon storage by using the Banco model. So 9 soil carbon storing practices were selected based on the literature review. I was in charge of the second practice analysis, the potential of cover crops. So no tillage was also considered, considering new carbon inputs that are not already spread on agricultural soil under current management practices, expansion of temporary grasslands instead of silage maize, for instance, agroforestry, hedges, some moderate intensification of the extensive grasslands, animal grazing instead of mowing, and grass cover of vineyards. And for each of the selected practices, its potential applicability was calculated by considering the technical constraints. For instance, you cannot grow cover crops when you have a fallow period that is below 2 months. And then the additional carbon storage was assessed following the implementation of the carbon storage practices. So it was assessed by using some modeling approach at a fine scale resolution, which is about 1 kilometer. And in each grid cell was characterized by some dominant land use, local climate, some data concerning the soils, and initial soil carbon storage values were also accounted for, as well as the dominant cropping system. 2 models were used. For cropland, it was the STIX model that was developed by INRA. So I won't go in details. There are some inputs for the model, like climate, soil, vegetation. For the PASSIM model that was used for simulating grasslands, it's more or less the same kind of information that you use as inputs, and then you can model different things like the carbon, the greenhouse gas emissions, the forage provision, and so on. And both models include an explicit representation of the carbon cycle, of course. So for each grid cell, which is important to understand, is that we have calculated the change in soil carbon stocks for a period of 30 years under the current management practices, what we call the baseline, and under carbon storing management practices, so for instance, expansion of the cover crop. So when what we want to address is the difference between how the carbon stocks change in the soil under the current practice, and between the amount of carbon that will be stored in the soil after 30 years of changing the management practices. So it's this difference, the additional carbon storage, that we want to address between the baseline scenario and the carbon storing farming practice. And also important is that simulations were performed for the first 30 centimeters of the soil, and then extrapolated to the whole soil profile. And for each carbon storing practice, a complete greenhouse gas budget was calculated. The way the cost assessment was performed, so we estimated some additional cost. So that means the cost of the carbon storing practice minus the cost of the current practice. And the cost can be negative or positive, of course, and it is calculated by considering the differences in overheads, differences in inputs between the two practices, differences in crop management operations, so more work, for instance, to seed the cover crops and to destroy them compared to a system without cover crops. Considering if some dedicated investments were needed or not, if there was a change in the revenue of the farmer based on the difference in the yield, new revenues eventually for agroforestry when they say the wood, some change in land allocation could be accounted for, and we excluded some optional subsidies, the fact that there would be some changes in the cap payments, for instance, for this or that crop. And it was considered that there was a constant annuity with a 4.5% discount rate. So the costs were calculated for each carbon storing practice and each French region. So the Banco model was used for that. The data, the inputs for the model are the costs for farmer, depending on the practice and the region. So the number of euros per hectare and per year to implement the practice. The additional carbon storage was calculated. The potential applicability was accounted for, depending on the region and on the practice. The compatibility between the practices were accounted for also. And then by defining some national additional carbon storage target, the uptake level, the marginal carbon storage cost were calculated, as well as the total carbon storage cost, which allowed my colleagues to produce a marginal carbon storage cost curve. This is the marginal cost, and here you have the cumulated additional carbon storage, and when you define a certain target to how much carbon you want to store per year, it defines what is the marginal cost. So that would represent the cost of the last ton of carbon that has been stored in the soil. Some results. So first, when we analyze the baseline, this is the carbon storage under the current farming practices for croplands only. So that includes arable crops and temporary grasslands. So here you see the map of the carbon storage in France, depending on the regions. You see that there are some areas where there are some carbon losses in the soil, others with carbon storage. And on average, if you consider croplands without the temporary, the areas without the temporary grasslands, you see that most of the time there is some carbon loss over the cropland areas. While when considering the crop rotation with temporary grasslands, most of the areas that were simulated were storing carbon, around 260 kilogram carbon per hectare per year. So then we tested the effect of different changes in management regimes, and in this on the next slides I will focus more on the scenario considering the expansion of the cover crops. You have to be aware that this practice already exists in some areas in France. You see on this map that cover crops are present in many areas, but usually they are not present every year in each area, so they are included in the crop rotation. So this represents the percentage of the intercrop period with a cover crop during a crop rotation. And you see that in the areas where the cover crops are present, usually they are present in the crop rotation less than 50% of the time. So in the scenario with the expansion of the cover crop, you see that first, the areas in which the cover crops are present, their surface increase, but also their frequency in the crop rotation increases. And the potential applicability of this scenario was important, high, because it represented close to 96% of the cropland area. How much carbon does that allow to store? On average, it's about 126 kilogram of carbon per hectare per year, which is less than half of the number that we find in the literature. But the reason is that it's because cover crops were already present, were already there in some areas. But you see that anyway, most of the areas where cover crops were added, expanded, the carbon storage is above zero, so there is most of the time some additional carbon storage, which is often not very high, but significant. Where does that happen? Well, you see on this map that there are some areas like around in the Bassin Parisien in southwest France, where most of the carbon storage occurs when you add some cover crops. There are some areas like here in Bretagne where there is less or sometimes even some losses, so less carbon storage or some small losses. And this is due to the fact that in those crop rotations they already include some perennial temporary grasslands, which provide less opportunity for incorporating new cover crops. And by contrast, there are some areas with much higher carbon storage potential that corresponds to the arable cropping system of the Parisian Basin and the southwest France. One thing that you have to be aware of is that, and that was a bit discussed this morning, that cover crops are also interesting because they offer many other ecosystem services, including some additional climate mitigation effects through albedo increase, through N2O reduction, through decrease in surface temperature or heat fluxes. And if you sum of those climate benefits, that would at least multiply by 2, the 1.5, 2 or even more, the climate mitigation effect. So it is a very interesting measure in this perspective. So when we summarize, when we aggregate the results for all carbon storing practices at national scale, so here on this slide it's only for the arable cropping systems. You see that per surface area, per hectare, the cropping, the management practice that allows more carbon storage is agroforestry, followed by expansion of cover crops and the expansion of temporary grasslands. But as the cover crops represent, they can be implemented in the larger areas at national scale. It's this management practice that allows by far the more additional carbon storage in the soil. So in total, and also for concerning no-tillage. As I mentioned earlier, the simulations were done only for the 30 centimeters in the soil, but when you integrate all over the soil profile, that would be, oops, sorry, this number would actually be 0, because if you add more carbon in surface with this practice, you lose deeper in the soil. So when you integrate all over the profile, the effect is nil. So in total, the change in practices for arable lands would allow to store close to 5 megaton of carbon per year, and that represents a relative yearly increase of the soil carbon stocks of 5.2 per mille, which is above the limit of the 4 per mille that was discussed earlier. Be aware that this carbon storage effect is limited in time. For instance, when we are implementing cover crops, you reach a new equilibrium after 45, 50 years in France. At least that's what the models say, which means that after that, you have to maintain the cover crop to keep the same amount of carbon in the soil, but you will not add more carbon. No, here. Considering the the grasslands and the vineyard, well, on the vineyards, the potential for storing carbon by putting some grass cover is very low. For grasslands, it's the moderate intensification of the extensive grasslands. Mostly it means adding more nitrogen in those ecosystems that allows to store some additional carbon. And in total for the French, but it's much less that the lever that we have over the arable lands. And in total for France, for the French agricultural soils, the potential for adding carbon storage is 5.78 megaton of carbon, which corresponds to 3.3 per mille. So a potential for additional carbon storage of 4.78 megaton of carbon per year, as I was saying, in the first 30 centimeters of soil. This represents an annual increase of 5.2 per mille for croplands, 0.9 for grasslands, and 3.3 for all agricultural soils. And this potential is mainly found in the arable soils, as I mentioned earlier, 86% of the total potential. And partly this is because the agricultural soils are very depleted in organic matter, of course. When you extrapolate that number to the whole soil profile, that additional carbon storage would allow to compensate close to 7% of the national greenhouse gas emissions. And it's mainly here in those areas where agriculture and arable lands are very present that we could store a lot of carbon. Now, since this seminar is about bioeconomy, we'll talk about the cost of all that, of course. So I'm not a bioeconomist at all, so I hope you won't have too many questions about that, but I'll try to answer if it is so. So some numbers. There are 3 groups of management practices. The one that actually do not cost anything and even can put you more money in the pocket. So that corresponds to the using new carbon inputs and applying some grass cover over the vineyards. So the storage cost, the amount of euro per ton of CO2 that is fixed or compensated is quite negative for the new carbon inputs. Considering the cover crops, the moderate intensification of extensive grasslands and the grazing instead of mowing, you see that it represents a moderate cost. And then there are some other actions that have a more important cost. So this was accounted for to estimate where and which management practice implement by analyzing those marginal cost curves. So you see that with no incentive, so by considering €0 invested to store a ton of carbon. It was the grass covers and the vineyards that could be implemented, but that represent a very small compensation of the greenhouse gas emissions and a very small per mille with a negative cost. By considering the current carbon price, so €25 per ton of CO2, cover crops could also be considered in some areas and temporary grassland also. So would allow to store more carbon and compensate close to 1.3% of the national emissions. And it's the cover crops that would do half of the job, let's say, followed by new carbon inputs. And it's mainly here in this area of France, the Centre Val de Loire, that it could be implemented. And now, by considering the shadow price of carbon in 2020, considering it would be €55 per ton, you see that you can, of course, store more carbon. You can implement more cover crops, consider moderate intensification of the grasslands. I won't go all along the list. But then you could reach 1.52 per mille per year and compensate 3.3% of the national greenhouse gases emissions at a total cost of €156 million per year. And there again, it's the cover crops that do most of the job. I will skip this one. Just to, and then I'm almost finished. So that would be the total cost, so €2 billion per year to reach the total potential for carbon storage in agricultural soil. And that would allow to compensate close to 7% of the greenhouse gas emissions in France. So to conclude, there is technically a potential for additional carbon storage of about 4.78 million tons of carbon per year in the first 30 centimeters of soil. So that represents a relative increase of 3.3 per mille for the agricultural soils. This potential is mainly found in the herbal soils, and that's 86% of the total potential, and partly because the initial soil carbon stocks are low there. Extrapolated to the whole soil profile, this additional carbon storage, as I said, would compensate close to 7% of the national greenhouse gas emissions, and about half of this potential is at a lower cost than the shadow price of carbon, which is very interesting. And the optimal combination of the carbon storage practices, of course, they depend on the regional context. And I didn't talk about the forest in the presentation, but in very short, it was considered that the forest in France, they already are at the maximum of the potential, whether you agree or not on that. But that's what the expert from the forest systems considered for this study. So thanks a lot.